Okay, what were all four of these DOMs? All four of them were undefined. We are reaching a point in the year where we're going to be like playing popcorn pre-cal. We're going to be kind of jumping all over the place and doing things here and there because there's certain things I want to spend a lot of time focusing on, and there's other things we're going to come back. We're going to finish everything I really want to hit with like a month to spare. And in that last month, we're going to do a little review for the final every day, and we're going to go back and look at a section we've skipped every day so that we can talk about them briefly. This is a classic example of a section that I don't really want to spend a lot of time on. 4.6, which you don't have to make notes for because this is all we're going to do in it, graphs other trig functions other than sine and cosine. Tangent, for example, is the big one. Tangent is just sine over cosine. So, all of these that you got undefined, you were correct. And every time you get undefined, who remembers what that means on a graph if you get something over 0? On a graph, what does that look like? You might remember? It's a vertical asymptote. The graph of tangent is a headache because it has asymptote, 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 asymptote. You have to keep doing all these. Graphing tangent and cotangent and cosecant and secant, no, they're not hard. You just have to make XY charts for them because you're going to have so many stinking undefined. And that's just the way it is. We're not going to spend a lot of time on it because A, you could always use your graphing calculator to do that, and B, we've already studied vertical asymptotes, so I don't want to just go back and do another study in it. But if you can just remember that if you ever have to look like on an ACT or something, although I can't imagine you having to do that on the ACT, if you ever have to like graph tangent of X or answer a question about tangent of X or even cotangent, just remember it's going to be riddled with vertical asymptotes. So that'll help you just visualize, hey, that thing's going up and down like crazy. Must be tangent. That's like the whole point of the whole section, in my opinion. Another thing I want to briefly show you before we start today's lesson is, now I don't foresee myself being gone anytime in the near future, but should I get sick or something, at the very end of this chapter, there's a lot of questions like this, solving the right triangle, and there's another one we're going to look at in just a second. And they are excellent questions that you to do, and I thought whenever I have something happen, a death in the family, and I can't be here, for some unforeseen reason, I'm going to save these problems because they are worth doing. But I'm going to save them for a day when I'm not here because there's something productive we can work on. Because there's not a whole lot I can show you. We'll look at one or two examples just so that when that time comes, if it comes, you've seen it. But and you can put this. We're going to do two problems together. Put them like somewhere aside in your notes, and you can call them like rainy day problems. Someday when you come in here and there's 7 here, that's what you'll be working on. That way you'll have one or two as guidance when that time comes. Rainy day problems, and this is section 4.8 in your book. What does solve the right triangle mean? What am I solving? What am I finding? I'm finding everything. When you are asked to solve a triangle or any figure, that means you're finding every side you don't know and every angle you don't know. And the reason it's in this section is because you can use SOHCAHTOA to solve all of it. If A is 23.5 degrees, then what's B going to be? What was that? 62.5. Yeah, just subtraction. Now, if little b is 10, how can I find A and C? Hence, I just told you a second ago. SOHCAHTOA. Which one you want to solve first? It doesn't matter to me. A? Alright. Pick an angle. 23.5 or 62.5. It doesn't matter. 62. We're looking for A, and we're given B. You have to have a side to start with. From 62.5, which two sides are B and A? Yeah. No. Yes, it is 66.5. And that may have been what somebody said. I probably just mistaken. Thank you, 66.5. From 66.5, which two sides are we given? Opposite and adjacent. Which trig function uses opposite and adjacent? Tangent. So tangent. 66.5. And you may want to make your notes, because I know a lot of you, when you come back and look at these, you're like, oh, wait, why did he choose that? So you might want to make a note saying, we used tangent because we have the opposite and are looking for the adjacent. I'm not going to do this every problem, but don't just think that it's always tangent. It's not. It depends on what you're looking for. Oops, adjacent. There we go. So, tangent of 66.5 equals opposite over adjacent. That's an A, not a 9. Now, who can tell me how to solve for A? The common misconception here is divide by 10, and you think everything is good in the world. But your A would still be in the denominator. Exactly. You're going to multiply by the A. That becomes A tan 66.5 equals 10. And then divide by tan 66.5. So you get A equals 10 divided by tan 66.5. If I punch this into my calculator right now, it's going to give me a wrong answer. Why? Who can tell me why my calculator would give me a wrong answer right now? It's in radian mode. If we're using degrees, you need to be in degree mode. So, mode, boom, boom, degree. So here we go. 10 divided by tangent 66.5. Oops. And A equals 4 points. Let's see, it says 2 decimal places, I think. 4.35. 4.35. From here, you're more than welcome to use Pythagorean theorem. But I think it's good practice for us to just keep using trig. So let's go from 66.5 again. Now, when you're looking for C, you now have two sides that you could choose to use. However, which one did we round? A. So let's just use B so that our answer will be as accurate as possible. If you use a rounded number to find another answer, it's going to have a bigger margin for error. So, from a 66.5, which side is B? Opposite. And which side is C? Big H word. Hypotenuse. Which trig function uses opposite and hypotenuse? Sine. So sine 66.5 equals opposite over hypotenuse. And just like the last part, those two are just going to flip. C equals 10 over sine 66.5. So 10.9. And now we have solved the triangle. We have every side and every angle. Again, these are rainy day problems. I can't tell you exactly when you'll have them, but you will have them most likely. Well, I can't find this. Questions? You aren't even going to have to do this today, so that might seem frustrating to you. But I want you to have seen them. The other one we're going to look at is something like this. Now on these, you're just solving for the missing variable, in this case, x. Let's brainstorm here. Who can raise your hand and tell me a game plan for solving this problem? All of these are going to be a little different. You have to do something a little different every time. So we have to use some outside-the-box thinking here. How can we solve for x? Only using what we've learned so far, which is toe-to-toe. Yes, sir. Exactly. Look at these two right triangles. You have one right here underneath that line, and you have a big one. If we use 25 degrees, it'll find this piece. If we use 28 degrees, it'll find this piece, and then we can just subtract and find x. Very good. So let's call those, we'll call this height 1 and then the whole thing will be height 2. For height 1, does that go with the 25 or 28? 25. So we're using opposite and adjacent, which is tangent. Tan 25 equals opposite over adjacent, and then just multiply. 600 times tan 25. What? Oh, was it 600? Oops. There we go. 279.78. H1 equals 279.78. Now we'll find H2 doing the exact same thing, except now using the 28-degree angle. And that's H2 over 600. We're going to punch it into the calculator again. So now it's 28 degrees. 319.03. So we just subtract, and that will give us our x. Yeah, I'm not really going to do this long one. 319.03 minus. Of course, if somebody can do this in their head faster than I can type it, then please just tell me. 39 1/4. X equals 39.25. Finish. Mathematically, it's not horrible. The hardest part of these problems is discovering how to find your given x. They won't all look like that. Some of them will look completely different. You'll have to use a different set of logic. But they'll all be similar in mathematical breakdown. Questions? Okay. Now we've done all this and haven't started today's yet. But don't worry, today's is short, I promise. Today we are skipping all the way ahead to chapter 6.1, and you can finally start actual notes. Although there's really only one thing going in your notes and then just a few examples. One thing, uno. And that is, and on top of the fact there's only one thing, I'm extremely positive you've seen it before, the law of sines. The law of sines is like this. It's a proportion. A proportion based solely on the fact that in a triangle, the bigger your angle, the bigger your side. In geometry, you had to do a bunch of stuff where it showed you a triangle and it said which side is going to be the biggest. And you had to pick the side opposite the biggest angle. Which side is going to be the smallest? Side opposite the smallest angle, etc. This proportion is based solely off of that logic. Everybody got this written down? That should be the only piece of notes you have, and then we'll just do a few examples. Okay. Solve each triangle. Just like the last ones, you have to find every missing piece. What's my missing angle? I think it's 42, right? Ooh, making it isosceles. Who remembers what the base angles converse told us in geometry? What do we know about A and B? They're equal, so let's just find one of them. Now, to use the law of sines, you have to have a side and an angle opposite that side. Do we have that? Yes, we do. We have 96 degrees, and we have 12. So we have one whole portion of the proportion, which is what we need. Now you want to solve for A or B. It doesn't really matter. They're the same. A. Oh, I got it backwards. Sine 42 over A. Again, you'll need to be in degree mode, but you should already be. Cross multiply to solve your proportion. Divide by sine 96. And click her on into your calculator. Clear. 12 sine 42 divided by sine 96. And I'm getting 8.07. Oh, it says the nearest 10. 8.1. Which therefore also makes B 8.1. They won't always be the same, but if it's an isosceles triangle, then they will be. Questions on that? They're pretty much all going to be like that. There might be a little twist and turn here and there, but all the problems are going to set up just like that today. Next. Let's just set them up. I'm confident you can cross multiply and do all that stuff. What's our side angle pair here? If I could give an MVP for the day, you'd be it right now, Joey. You're just answering everything, and I appreciate that. Now, what's my last angle going to be? 40. Yeah. So, to solve for the other two pieces, you'll do sine of 40 over B. And then you'll do the exact same thing again, but do sine of 102 over C. Why can't we just use Pythagorean theorem to finish this? It's not a right triangle. Very good. You can only use Pythagorean theorem on a right triangle. So you'd solve those two proportions for B and C, doing the exact same thing we did on the last one, and you're done. I guess technically the best way to answer this would be to write somewhere on your paper, angle B equals, side B equals, and side C. That way the answers are all right there. Questions about the setup? Okay. Same thing. They just didn't give us a picture. We just have to use data that they've given us. So let's pick one at random. How about 13? On 13, do we have a side angle pair? Yes. What is it? Very good. Sine 35 over 200. Now what's my last angle going to be? What's angle B going to be? 30. So that's going to be, let's see, sine of 115 over A, and sine, we'll do the same exact thing again, and do sine of 30 over B. Sine of B over B, sine of A over A. And then from there, again, you're just cross multiplying and solving. People tend to look at these signs and kind of get freaked out about how to solve them. Sine of a number is just a number. So you can treat those just like it was 2 over 200 equals 7 over A. It's going to work the same way. You can cross multiply, divide by whatever you want. They're just numbers. Although I would wait to punch in, get those numbers until the end. That way you're not dragging some ugly decimal all over the place. Questions about that slide? If you want to take a look at some of the others and say, well, how would that one set up? I'd be happy to answer that. Because there's no duplicate, right? But what's angle C going to be? Yeah, add them up, subtract from 180, and then you'll have a side angle pair. Good question. Other questions? All right, let's just do it then. There you go. Told you it was short.